So if we look at the advantages that the 9155 has over our competitors, it more or less falls into one of these 5 categories: technical excellence, speed of calibration, simplicity or ease of use, flexibility, and reliability. And all of these come together to form the ultimate goal of a calibration system for both us and for the customer using it, and that is confidence. The customer needs to be confident that the system they are purchasing and using is going to give them good results, so that they have confidence that when they're using these accelerometers in testing, they're getting the results they're expecting, that their sensitivities are good and the performance of the accelerometers are good. So all of these feed back into this idea of confidence. Today we're starting with 2 of the 5, and that's simplicity, or ease of use, and flexibility. So first, before we go into the details of those, we're going to step back and say, what does it take to make a simple and flexible system? And this is an area where the modal shop it can be seen as a little unique compared to a lot of our competitors. For one, it takes a lot of experience and a lot of customer interaction. When we design the system and come up with design input specifications, we sit down with our engineers, the product management, the sales, sit down with the engineers, and we talk about what we think the right solutions are. But in the end, the engineers, the sales guys, and me are not the ones using the system. So while we can guess on what we think is important for the customer, to truly design a system that is both simple and flexible takes a lot of communication with customers, and that can only come with years and years of working with customers, getting their feedback, and building strong relationships with them. So starting with simplicity, why does a customer care if a system is simple? First of all, unless they are already performing vibration calibration, they're replacing an existing system, most of our customers that buy a 9155 system are new to vibration metrology. That's not to say they're new to metrology, just the subset of vibration metrology. And anytime you're trying to pick up a new skill, it can be a somewhat daunting task, especially when the skill you need is a precision-based one, where you need to have confidence and you need to know how to perform the calibration. So if you can find a simple system that takes your focus away from the intricacies of software and hardware and lets you focus on the test method, that's going to make your job easier and going to make your results better, and you're going to be more confident in your results. The second one, many of our customers aren't continuously using the system, especially with the 9155. One of our other key advantages from the first slide is the speed of the calibration system. And with the speed of the calibration system creates another challenge. The system is so fast that many of our customers will be able to calibrate all their sensors in less than a month, which means that if they have, say, 500 sensors, it takes them 1 month to run through all 500, and then the systems won't be used until it's time for calibration again, roughly in about a year. Now, that's of course not the case for all customers. Regional labs will use it pretty often, but not everyone is in that boat. So again, you need to have a simple system, so when you are relearning how to do the system, redo the calibrations after 11 months, the learning curve of remembering is short. And then, of course, we all know that if you have a simple interface, you're less likely to have errors, to make mistakes as you go through the calibration process. So now we're going to look at how we make the 9155 simple. And there are a lot of different examples of how this system is simple for our customers to use. And we're going to focus on a couple of them. The first we're going to look at is something that we do before we even sell a system, and that is to ask for a list of sensors from the customer. In a little bit, we're going to talk about flexibility, and one of the reasons the system is flexible is because of all the options that we have and the number of configurations we can put together for the customer. With a lot of options and a lot of configurations, that makes the system complicated. Since we want to keep things simple, we ask for the sensor list so we can take the burden of specifying the proper system off of the customer and instead make a recommendation based on the customer's sensor list what system we think that they should look at purchasing. It also removes the burden of figuring out if they have all the cables and mounting adapters that they're going to need to calibrate their sensors. Our goal when we show up at the customer site is that we pull the system out of the box, assemble it, ensure it's working properly, train it, and they have everything they need to calibrate all of their sensors. That is our goal. The other thing we do with the sensor list is to add the specifications to the system database. And I'm going to change over to the 9155 software here. If we go to the model number template database, every system we deliver to a customer has this running list of sensors that we've added in. We've got Devco, Kistler, PCB, Unhold-Sticky, Dytran, Columbia Research, lots and lots of PCB, of course, CEC Technologies, Measurement Specialties, Brule & Care, Devco, Kistler, and so on. Every time we get a sensor list, the sensors get added into the master database. So every time a customer purchases a system, not only do they get the benefit of all the previous sensor lists that we've collected, they get their sensors list added in also. And by adding their sensor list in, they're helping to grow the process so future customers continue to receive the benefit of these specifications already being entered in. This saves the customer lots of time in figuring out how to enter the stuff in when they receive the system because it's already done for them. So that's another example of how the sensor list helps us keep a simple system. Other areas that we create a simple solution, a simple offering for the customers. If we look at the hardware, starting with the air bearing shaker, it has built-in anti-rotation locks. It has a very easy centering mechanism. There's no rubber bands to adjust to center your payload. There's also low pressure detection in the Smart Amp. This first and third one would seem more like a reliability one, but it's also related to a simple system as well. Because if you are confident that when you use a system, even though you might not remember all the details of the setup, if you're confident that the system has protections that's going to stop you from being able to do something you don't want to do, like run your air bearing shaker without air pressure, you're more likely to go ahead and try to use the system and not worry about having everything hooked up and reviewing mounds and mounds of documentation to get everything hooked up correctly. We, of course, have all the documentation. It's easy to follow. But the point is that even if you make a mistake somewhere along the lines, the system will protect itself. The other area that the system is simple is in the signal conditioning. By that I mean the computer-controlled ICP and charge signal conditioning. For most sensors that customers calibrate, it's completely hands-free. They don't have to push any buttons. The system will automatically set the conditioner to the appropriate setting. And then, of course, the TEDS update. If we look at software, and again, there's many different ways that the system is simple, we'll look at two areas briefly here. First is the in-software help notepads. This is a somewhat new feature, and I'm going to come back to the software here. One thing you'll notice is in all of the panels, there's this little question mark in the top right-hand corner. If I click it, it launches a editable Word document. And this is completely editable by the customer. In many cases, it will be used to create or to store calibration procedures. It can also be used for some helpful tips and pictures of what you need to do next once you're on the screen. So if you just opened up the system after 10, 11 months of not using it, you're trying to remember what the next step is, this is a very powerful tool to help you remember what you need to do. You click the button, and it'll pull up your procedure and say, here is the process that I need to follow in order to perform the calibration. And again, this is completely editable by the customer. So any notes that they want to take as they go through can be added in and saved and brought up the next time. The other one is the calibration process itself. To complete a calibration, there's 4 clicks or 4 operations that need to be done to complete that calibration. And I'll go through those briefly here. The first is to select the sensor. That's driven by some simple drop-downs that come out of the database. This is the sensor that's already selected. The second one is to select the test that you want to run. So we'll run a frequency test. Third is to run the calibration. And at this point, once we start the calibration, the system goes through its safety checks and then starts the calibration process. And even if we have a sensor that's out of spec, it's a very easy interface to see where the failures are. Pops up bright red and lists exactly what the out of tolerance condition was. And once the calibration is complete, the fourth click or fourth process is to save and print the calibration results. So at this point, the calibration process is done, and I'm ready to go down to the next sensor. 4 very simple steps, and that also ties into one of our other key benefits, which is the speed of the calibration. As you noticed, it took 30 seconds to perform that calibration. So now we're going to change our focus over to the flexibility of the calibration system. The reason customers care about flexibility in calibration systems is that any time you're working with a system, especially one that has lots of functions and lots of capabilities, you're going to have different requirements from different organizations and different philosophies of operation. Accreditation requirements can vary from country to country. The accreditation requirements from A2OA are somewhat different from the accreditation requirements of, we'll say, UCAS in the United Kingdom. The business model of the company can be different. If you focus just on regional metrology labs, you can go about getting your calibration business a number of different ways. You can, of course, compete on price. Many companies do not like competing on price because it cuts the margins. They try to find other ways to compete. So you compete in accuracy, you compete in turnaround time, and there's probably some other ways too. And also the needs of the system user. For example, if we look at the needs of the mobile shop as a calibration facility and the needs of Boeing, they are drastically different. At the modal shop, we maintain a rental inventory, which means we need to be able to calibrate sensors quickly and move them out the door. We want it to be accurate too, of course, but an annual calibration is probably more than what we need for our rental inventory. If you look at a company like Boeing, they don't have as much value on the speed of the calibration. Instead, they're going to test every sensor before and after every test. So they need to do things like compare current results to previous results to make sure sensors are working properly. So it's important in that regards for a system to be flexible, because if a system is very rigid, then the companies need to change their process and change their modeling, their business model, to match the system. Or if the system is flexible, you can make the system match your current business model and your current needs. So that's why the flexibility is important in terms of the organization requirements and philosophies. And of course, there's also different regional considerations as well, language and paper size being two obvious ones. So again, I'm going to change over. Oh, no, I'm not. Got ahead of myself here. I'm going to continue going. The other thing that makes the 9155 flexible is in the modular configuration. This is one that I mentioned earlier. If we're specifying a system for a defense company, they're probably going to be interested in 20 kilohertz calibration, and they're probably going to be interested in shock. Where if you look at someone that's doing seismic and civil infrastructure, they're not going to be doing any shock at all, and their frequency range is also going to be much lower. So through a modular configuration, we can tailor the systems to exactly what the customer needs so they don't have a bunch of extra hardware that's not going to be used. That keeps their costs down, of course, and it also gives them a system that matches their exact needs. And then the last area we're going to talk about are in the calibration certificates. The calibration certificates are all created in Microsoft Excel. Everyone knows how to use, almost everyone knows how to use Microsoft Excel very well. So if we go to the certificate, it's very easy for us to come in here and add a logo down here in the bottom left-hand corner, or to add an A2LA accreditation stamp, or whoever the local accreditation body is. To change the notes, we want to change % deviation to sensitivity instead. That's easy to do. It's all through Excel. The other thing this allows us to do is to change the certificates into local language. I have a couple examples that I'll share here. This first one is a calibration certificate created by the National Lab in Russia, who is using our 9155 calibration system. I don't think we have anyone from Russia in here, so that means that most everyone in this presentation won't be able to read most of these parts. But for the local area, it makes perfect sense for everyone, and it's easy for it's clear. It's clear to the customer. We don't have to rely on them speaking English to be able to understand the certificate. Another example is one from our friends and distributor there in Brazil at Signalworks. Again, all translated into Portuguese. You have the plots. They even tailored it. It looks nothing like the other calibration certificates, yet it's created by the 9155. It's been tailored to the way that the data to the customers. Frequency plots on page 1 with some notes. You got your table of results on page 2. And then equipment information on page 3. Also worth noting is that it's very easy to change paper sizes from 8.5 by 11, which we use here in the United States, to the A4. That's just changing a setting in Excel, and away you go. So this type of flexibility is a very powerful thing for customers. And what makes both the ease of use and the flexibility unique compared to a lot of our other advantages is that neither of these are things that we can specify on a specification sheet. Instead, we have to engage with the customer, we have to talk about the system, and in many cases, we should demonstrate the system to the customer so they can see the flexibility, see the ease of use, ask the questions on how they're going to get the system, how the system is going to work within their organization. One of the nice things about demoing with a flexible system is you'll go through the basic demonstration of the system, and then the customer will start asking questions. And if you have a flexible system, most of the time you can tell the customer, yes, the system will do that. So the customer might ask, can I compare current results to previous results? Yes, you can. Can I put my A2LA logo on there? Of course. Can it be in metric units instead of English units? Sure. And every time they ask a question, they start Tormund's vision of how it's going to work within their organization, and that is a powerful thing when it comes to which system they're going to decide to go with. So that's all I have for today.